Hello, welcome to the course Essentials of Data Science with R Software 2, where we are trying to attempt to learn the topics of sampling theory and linear regression analysis. In this module, we are going to discuss the topics of simple random sampling. So, as I told you earlier in the last lecture, that in this lecture we are going to talk about the confidence interval estimation of the population mean capital Y bar. And I am sure that you must have learned that what is the confidence interval estimation, but still I will just give you a very simple example to give you a feeling that why are we trying to do it here. Now, suppose I ask you a very simple question. How much time do you take in going from your home or say hostel to your college or say office? Think about it and let me know. Your answer will be say 30 minutes. But then my question is this exactly 30 minutes? In 30 minutes 0 second? Now you will rethink. It's not always exactly 30 minutes. But sometime it might be 25 minutes, sometime it might be 28 minutes, sometime this might be 30 minutes, sometime 31, sometime 32, maybe 35 minutes. But usually under normal conditions, this time will not be smaller than 25 minutes and more than 35 minutes. So, what are you trying to say now? Earlier you said you take 30 minutes of time, but now would you like to rephrase your sentence that yes, I take 25 to 35 minutes in reaching to my college or say office. So, now if you try to see the difference between the two sentences, earlier you said 30 minutes, now you are saying 25 to 35 minutes. So, in the first case that was the value of the time at a point. So, that is called as point estimate. And in the second situation you are trying to estimate the time, but this is in the form of 2 points and they form a interval. So, now you are trying to estimate the time in the form of an interval. So, when we are trying to estimate a parameter at a point, that is called as point estimator or say point estimation, and when we are trying to estimate the parameter in an interval, this is called as interval estimation. And when we say about interval estimation, then we try to construct the confidence interval estimation. Why confidence interval? For example, if I say that my question will be, what are the chances that you will take 29 minutes to 31 minutes in reaching to your college or office? And then I again ask you, what is the probability that you take between 25 minutes and 35 minutes in reaching to your office? So, definitely once I say 29 minutes to 31 minutes, that is a pretty close interval, and you are not confident that whether you can always reach to your college or office in that time interval. But when I say that your time is between 25 and 35 minutes, then possibly you feel more confident. So, with every interval there is associated a confidence coefficient, and when we are trying to state a confidence interval, then there are two components. One, we have to state the lower limit and upper limit of the interval, and secondly we have to state the value of the confidence coefficient. Confidence coefficient will in simple language will indicate your confidence or the confidence that the estimated value will lie between the lower and upper limits. Now, next aspect. Up to now, we have considered the estimation of y bar, capital Y bar, and we have found the estimate of variance of sample mean. In both the cases, we have not assumed any probability distribution. We have not assumed that your small y1, small y2, small yn, that is the sample values, they are coming from a probability density function like normal distribution or t distribution or binomial distribution or Poisson distribution or say anything else. But now, when you are trying to consider the confidence interval estimation, then we need to make this assumption. We need to associate a probability distribution function or a probability density function with my population. So, what we assume now that my population from where we are going to draw the sample, that is being characterized by the probability density function. Well, you can take any probability density function, but in this lecture, because we are at a beginner's level, so I will try to assume a normal distribution. So, normal distribution have two parameters, mean, which is indicated by mu, and variance, that is indicated by sigma square. So, mu and sigma square are the values of population mean and population variance, but in the population. So, here our objective is that I would like to consider here the estimation of population mean. So, I have two choices, this sigma square is known or unknown. So, I will try to construct here the confidence interval for the population mean under these two given conditions. Yes, what you are thinking, that is also correct, that what about sigma square? Sigma square is also unknown. Yes, if sigma square is unknown, then you can estimate it, and you can estimate it as a point estimate as well as confidence interval estimation. But surely here I am not going to do it, but that is available in any confidence interval estimation book, where the topic of confidence interval estimation under normal distribution is considered. So, I would recommend you that you please try to look into those books. So, now let me start this lecture. First, I will try to give you the quick revision of the result whatever we have found earlier, because we are going to use them here, and then I will try to give you a result which is going to be used in the confidence interval estimation. Although I believe that you know it, but just for the sake of say completeness, I will try to state it. Okay, so now first a quick revision about the symbols. So, that I already have done in the earlier lectures also. So, this y1, y2, yn capital, they are going to indicate the population of size capital N, small y1, small y2, small yn, they are going to indicate the sample values, that is the sample of size small n. Capital Y bar is going to indicate the population value, and similarly capital S square and sigma square, they are the quantities which are reflecting the population variance with the divisor n minus 1 and n. And small s square, that is the sample counterpart of this capital S square, and we had seen in the last lecture that this quantity also helps us in estimating the variance of the sample mean under SRS WR and SRS WOR. Okay. And you had seen that we had estimated the variance of y bar, that is sample mean, under WOR and WR, and those expressions are here like this: capital N minus small n divided by capital N into a small n times S square. And for the variance of y bar under WR, this is capital N minus 1 upon capital N into small n times S square. And in case if you want to estimate it on the basis of given sample, then these two quantities, they are indicating the unbiased estimator of population variance of y bar. So, this estimator is going to estimate the variance of y bar unbiasedly, and this quantity is going to estimate the variance under y bar w r unbiasedly. So, this is for your quick review. Now, let me try to state here a simple result. So, if we assume, say, let y1, y2, yn, this is a random sample, that means they are IID, identically and independently distributed, and this observations are coming from a normal distribution whose mean is indicated by mu and variance is indicated by sigma square, right. Now, in case if you try to define here a quantity y bar, which is actually your sample mean which you have considered 1 upon small n, I goes from 1 to small n y I, then I have here two cases. One is sigma square is known. Under this thing, y bar minus expected value of y bar upon the square root of variance of y bar. This will follow a normal distribution with mean 0 and variance 1. Right. So, in your case, you can translate it to small y bar, and expected value of small y bar in case of SRS WR or WR, it was capital Y bar, and the variance of y bar that you already have obtained under the two situation WR and WOR, right, which is here you can identify. I will just indicate it by another color red. So, this is the expression. Okay. So, this quantity will follow normal 0 1, normal distribution with mean 0 and variance 1. And similarly, when sigma square is unknown, then in that case the quantity small y bar minus expected value of small y bar divided by variance of y bar. But this variance of y bar cannot be estimated because sigma square is unknown, or equivalently capital S square is unknown. So, this can be replaced by its estimator. What is this estimator? You can see here. Now, I will try to indicate it with another curl. So, you can see here, this is the estimator, right. So, this quantity will follow a T probability distribution with n minus 1 degrees of freedom, right. So, in your case this translate to y bar minus capital Y bar, because expected value of small y bar is capital Y bar in both the cases SRS WR and WOR, but in the denominator this will be variance of y bar, and this can be used under the two condition, whether the sample is drawn by WR or by WOR, and this will follow a T distribution with n minus 1 degrees of freedom. So, these are the two results which I am going to use further in the construction of confidence interval estimation. Okay. So, now first I try to consider the case where sigma square is known. So, we assume that the sample is coming from a population which is normally distributed. So, it has got a normal distribution with mean capital Y bar, which is the population mean, and variance sigma square. So, we are assuming here that the variance of every y, that is every observation is the same, that is sigma square. Now, I have here two options, that is sigma square is known or sigma square is unknown. So, in this case I am assuming that this sigma square is known. So, under this condition, that is when sigma square is known, the 101 minus alpha % confidence interval for capital Y bar is given by this quantity, by this interval. So, if you try to see, there are several quantities which are written in this expression. So, let me try to explain you one by one. This quantity 101 minus alpha %, this is called the confidence coefficient, okay, and alpha is a value which is lying between 0 and 1, and alpha is also related to the test of hypothesis, where we try to fix the type 1 error as alpha. So, you might have heard that 95% confidence interval or 5% level of significance. So, alpha is the similar value, same value. Now, here there are three quantities, say here quantity number 1, quantity number 2 and quantity number 3. So, what are these things? Let me try to explain you one by one. So, first I come to quantity number 2, which is your capital Y bar. So, this is the parameter which you want to estimate, for which you want to find out the confidence interval. The confidence interval means the interval which is comprising of lower limit and upper limit. So, this quantity here 1, this is small y bar minus z alpha by 2 square root of variance of y bar. This is called as the lower limit of confidence interval of y bar. And similarly, if you go to this quantity number 3 here, this is called as upper limit of confidence interval of y bar. So, now you can see here that when you are trying to make a statement that you would like to find out the confidence interval of a particular parameter, this amounts to state that you want to find out two quantities. One is the lower limit and other is the upper limit of the parameter. Now, here also you can see there is one quantity here z alpha by 2. This z alpha by 2, this is indicating the alpha by 2% points on the distribution of normal mu sigma square. If you know the probability density function of normal mu sigma square looks like here this. So, if you try to, so suppose this is your here, suppose normal 0 1, and suppose if you try to say that this is alpha % point or this is alpha by 2% point on this side, alpha by 2% on this side, then this is suppose z alpha by 2 and this is minus z alpha by 2. So, this value of z alpha by 2 can be obtained from the tables. The tables are available which are computing the value of z for different values of alpha. Now, if you try to look at the interpretation of this confidence interval, this confidence interval is saying now my this capital Y bar is unknown to us. Now, we draw a sample. On the basis of sample, we compute the values of small y bar, variance of y bar, and we obtain the value of z from the table. So, I can compute the lower limit as well as upper limit of this interval. So, now I am saying that the probability that capital Y bar, which is unknown to us, will be lying between this lower limit and upper limit is 1 minus alpha. Right. How this interval is obtained? Well, let me try to first give you a quick review. So, as I explained you earlier that this y bar minus capital Y bar upon square root of variance of y bar, this will follow a normal distribution. So, I can say that suppose this is lying between minus z alpha by 2 and plus z alpha by 2. So, in a probability distribution function of normal 0 1. So, this is your here quantity z alpha by 2, and on the left hand side the quantity is z minus alpha by 2, and this area on the right hand side and left hand side, which is the shaded area, this is actually alpha by 2, and here is the mean. Okay, so, this value will lie between minus z alpha by 2 and plus z alpha by 2, that means in this interval, right. And I am saying that the probability of this event is 1 minus alpha. So, now what I have to do? I simply have to simplify this quantity in the bracket. For example, I can write down here y bar minus capital Y bar will be lying between minus z alpha by 2 square root of variance of y bar and plus z alpha by 2 square root of variance of y bar. And now, in case if you try to just solve this quantity, you try to solve that, what will be the limits for this capital Y bar? You will see here this is y bar minus z alpha by 2 square root of variance of y bar and y bar plus z alpha by 2 square root of variance of y bar, and this is here the same result which is given here, you can see here, right. Okay, so, I have given you one proof. Now, I will not be giving you any proof in the further slides, but they will follow exactly on the same line. So, now you can see here that you are trying to say that okay, I do not know capital Y bar, this is unknown to us, and if I try to find out this limit and this limit which can be computed on the basis of given sample of data, then the Y bar will be lying between these two limits. For example, if I say the probability that Y bar lies between 25 and 35, that means you take 25 to 35 minutes in reaching from your home to your office or college, suppose this is 0.95. So, that means there are 95% chances that the estimated value of capital Y bar will be lying between 25 and 35. And yeah, means you can choose the different values of alpha and you can create different confidence interval with different confidence coefficients, right. Okay, so, now I come to the second case where we assume that sigma square is unknown to us. So, again we make the same assumption here that the sample is coming from a population which is following a normal distribution, normal with mean capital Y bar and variance sigma square, and every unit has got the same variance sigma square. And when I am making this assumption here that the variance of every unit is sigma square, that also reflects the same discussion which we had earlier, where I indicated that how are you going to choose that, whether you have to use simple random sampling or say another type of sampling. So, you have seen that while we are trying to estimate the variance or this confidence interval estimation, we are assuming that the variance of y is actually sigma square, that means every unit has got the same variance. So, if your population has got a very high variability, that different sections of the population have got different variances and which are varying a lot, that means the simple random sampling may not give you a good outcome because this assumption is being violated, and that is my precise reason to give you this algebra. So, that when you are trying to do it for some bigger data sets, like as in the case of data sciences, then you should know whether your results what you are achieving are good or bad. So, now I am going to use here the result which we did discuss earlier, that is small y bar minus capital Y bar upon square root of variance of y bar and its estimator. This follows a t distribution with n minus 1 degrees of freedom. So, when sigma square is unknown, then this results hold true, and under this condition the 101 minus alpha percent confidence interval will come out to be like this. Now, you can see here this is the lower limit, lower confidence interval, it's a lower limit of confidence interval, and this is here the upper limit of confidence interval. And this value here t, this t alpha by 2 indicates the upper alpha by 2 percent points on the t distribution with n minus 1 degrees of freedom. The distribution of t and normal, they are more or less similar, and when these degrees of freedom are more than 30, then the t distribution and normal distribution, they becomes almost the same. Right. So, now you can see here we also have computed the confidence limit when the sigma square is unknown to us. Right. So, that is the same result what we have used, that I have written here more clearly for your records. Okay. That if the population is normal y bar sigma square, then this quantity follows a normal distribution and this quantity follows a t distribution. This is just for your records. Right. And here I am just trying to give you the algebra what I shown you manually. Once again, this is just for your records, that when you are trying to look into the slides, you should have a clear cut expression without any mistake. Right. And similarly, this is for the second case where I have computed the confidence interval when sigma square is unknown. So, my advice is that I have given you these expressions on this slide, so that you can try to do this algebra at least once with your own hand. Right. So, now I would like to stop here in this lecture, but now we have completed the theory part. We had a population whose population mean was unknown to us, and usually in practice we are very much interested in measuring the central tendency of the data. We would usually interested in the average values. So, this is the place, this is the theory which is going to help you, and these are the tools which are going to give you a clear cut answer. So, this population mean was unknown to us. Now, what we have concluded is that take a simple random sample, but before using the simple random sampling, you have to make sure that the variation in the population with respect to the characteristic under study, that is not very high. Means if you try to go to the different parts of the population, if you try to take up the samples, you must check. Well, you can do it by looking in the values from your experience, or you can also conduct the test of hypothesis also. But you have to first make sure that this is happening, only then you must use this simple random sampling. And if the variation is high, if the variation is changing, then another option is this: you can subdivide this population into groups such that those groups have got the same variability, but that we are not discussing here. We are going to talk about it when we consider the stratified random sampling. So, now you had the unknown population, you have found the arithmetic mean of the sample values, you also have found the involved variability, whatever estimate you have given, you have estimated the standard errors of the sample mean. They will give you an idea that how much is the variability involved in the values which you are trying to say. That means, if you say that okay, my sample mean is 20, so you are saying that okay, there is some variation also. So, the values are closely concentrated around 20. That is what we mean when we try to connect the concept of mean and variance together. Now, when we are trying to connect the concept of mean and variance together, then confidence interval also comes into picture. Now, you can see that when we have found the lower limit and upper limit of the unknown parameter, then they involve two components. One is sample mean and another is standard deviation or standard error. So, confidence interval takes care of the value as well as variation, and that is why the interpretation of point estimate and confidence interval differs. Point estimate says, okay, this value is concentrated only at this particular point, and the confidence interval says that the value is concentrated in this interval. So, one is saying the value is concentrated at a point, and another is saying that the value is concentrated in the interval. This usually you will see the midpoint of the confidence interval is the same as the point estimate when you are assuming a symmetric distribution like as a normal one. But if you take a different distribution, then this may not hold. For example, if you try to construct the confidence interval for sigma square, then we have to assume that this follows a chi-square distribution which is not symmetric. So, in that case this will not hold. So, what you are trying to say in the present case under the normality, that this is your point estimate and all the values are lying in the interval around this point estimated. So, that means when I say around, this is taking care of the standard deviation or standard error, or in simple words the variability of y bar. And what do you mean by variability of y bar? You have seen that once you have a population of size capital N, then you are trying to take a sample of size small n. Different samples will give you different values of sample mean. So, now with these tools you can study that how much is the variation and what do you expect, with what confidence or with what probability that your estimated value will lie between these two intervals. So, that is all about the theory. Now, in the next turn I will try to take up the issue that how to compute these things on the R software. That is pretty simple, straightforward. So, you take care of yourself, try to practice, try to revise the concept, so that you are 100% prepared with this concept to employ on the R software, because we need to write small functions and we need to take interpretations, and I will see you in the next lecture. Till then, goodbye.